everyone, and welcome to week 2 of ABAP Cap Mondays of DevToberFest 2024. We hope you enjoyed all the DevToberFest sessions until now and also participated in the various activities of DevToberFest contest. Please remember that the grand prize is a retreat at an SAP TechEd Roadshow stop in 2025. The current session is about testable mechanisms with ABAP Unit, presented by Sunil Bandavirapalli. Together with Sunil, we have Abin Bedi, who will be answering your questions in the chat. So let me welcome Sunil and Abin to DevToberFest. And now over to you, Sunil.
Yeah. Thank you, Sheena, for the introduction. And hello, everyone. Welcome for today's session on testable mechanisms with ABAP Unit, your friend in achieving effective test automation. So in this session, we are going to see today few prerequisites that are needed for this session. And then we will look at some of the key takeaways that you can expect from this session, which is like why writing stable automated tests is slightly challenging and it requires some skill, and more so in ABAP, and the challenge to deal with various types of dependencies in ABAP, and then how to manage these dependencies in our source code using different testable mechanisms that are now offered with ABAP. So since there are a plethora of testable mechanisms that are being offered, so often there will be a challenge or a confusion of okay, when to pick what. So we will also see in the end as a summary of which one to pick in which context. So, and with that, we will also come to the question answers. So as Sheena just mentioned, so we would be continuously answering your queries in the YouTube chat by Abin, my colleague. And in the end, if time permits, maybe we can also take up some of the queries if they are not answered. Okay, with that, now let's see what are the few prerequisites for this session, which we are not going to cover in this session. So ABAP Unit, we expect that you are already aware of ABAP Unit concepts. So if not, then please go to our SAP Help portal, where all this is documented really nicely. So that is a prerequisite. We will not get into the details of ABAP Unit in this session. So this session's purpose is just to deal with challenges that are involved while dealing with dependencies while you are writing ABAP unit tests. Okay. So now with that specific agenda in mind, so now let's get into the topic. So why writing stable automated test suite is challenging, and also it requires some skill, especially by managing different types of dependencies in ABAP. So before getting into that, let us just also go through some of the terminologies that we are going to use in this session, which you can also use it later as a reference. So one is the code under test, the code that the scope of the test, right? So the code that is under test scope. So that we can call it as code under test, or CUT as an abbreviation, wherever you see that is code under test. And then dependent on component are basically the dependencies that you have from your code under test is dependencies or dependent entities. So technical term for that is dependent on component, or the acronym is DOC. And very important term, the test double. Okay, that's what this session is about. So it is a test replacement for a given entity. Okay, where that given entity is being completely replaced by this test double in some form. Okay, so that means it will completely replace its logic or behavior, the existing logic or behavior of the entity. So there are various kinds of test doubles that are defined in XUnit patterns. But we use typically two types. One is state-driven verification. The other is interaction behavior-driven verification. So state-driven verification, we call it as stub, whereas for interaction behavior-driven verification, we call that type of test double as a mock. So we took some liberty in having these terminologies from what XUnit differs, just to easily communicate the point to you and help you learn. So basically, the state-driven verification means you basically drive the application state to a particular point with some test data, and then you test the scenario that you want to test. Okay, so it's state driven. Okay, whereas a mock or application interaction behavior driven verification is so each and every interaction that your source code would be having with the dependency. So you configure that interaction with how you would like it to desire, how you would like to behave in your test. And then there are certain mocking APIs that are provided from that framework. So that is basically the interaction behavior. It's interaction between your code under test and the dependency. That's what you can configure. So that is about one more type of test double. So you would see that various test double mechanisms that are there either use one of these two mechanisms. So, but this complexity you don't need to bother in general. So because we named it as generally test double mechanisms as a generic term. But the reason why I'm introducing these two terminologies separately here is that sometimes when you're learning these different test double mechanisms, it is maybe helpful to understand the nature of it and how it is designed. If you know this distinction, then you can probably understand these test double mechanisms better and with lesser confusion. So that's the reason why I'm introducing this. But otherwise, you just need to bother about just test double. That's it at the high level. And then the TDF as an acronym we use like a test double mechanism or a test double framework. So this TDF is something that you would see quite often being used in our presentation. Now, as I just mentioned, so for further references for your learning, we recommend to follow the XUnit test patterns or XUnit testable patterns by Gerard Mesures, and also a few very good, well-written blog posts from Martin Fowler, like mocks and stubs. So now, having covered the basics, now let's get into the topic of unit testing first. From there, we will get into the dependencies. So I have a piece of code that I want to write a test for. So that's my code under test. And the test that I'm going to write, we can call it as a test case. Now, typically, we will not write our code as a standalone one. It's very rare. We will depend on some other artifacts, some other classes, some other like database mechanisms or database artifacts. So we will depend on something outside that code under test. So these are like dependencies or dependent on components. Now, when I'm writing unit test for this source code, code under test, so my goal should be that any test failure, when the test case fails, then my goal should be to ensure that the test failure is happening because of some issue with this code under test alone. But then what we often see is that the dependencies are kind of variables and it will not be in our control completely. And that was a challenge to the outcome of our test case execution. So when the test case fails, I don't know exactly where the problem is, and that kind of poses a challenge in troubleshooting the problem, because now the problem area to troubleshoot becomes a lot more wider, because you have code under test and then you also have dependencies. We don't know where the issue could be, right? So that's where, when my focus is to test a particular code that I have written, often the challenge comes for writing that test, having stable tests. Often the challenge comes from the dependencies that I'm having from the source code, because that will not be in my control. And now in ABAP, the challenge is little more, I would say. Why? Because um, in ABAP, we have different types of ABAP objects. As you know, like there are this ABAP object-oriented artifacts like classes, interfaces, um, and there are this dictionary objects like CDS, AMDP, and there are also like bodies, wrap business objects, etc. Right? You also have this ABAP SQL statements, EML, so on and so forth. Different type of ABAP objects, and these ABAP objects, each of them also will have different type of dependencies. Right? The dependencies again could be ABAP object types like classes, interfaces, or function modules like the call function statement that you can have, or the database dependencies, ABAP SQL statements and CDS, AMDPs. As I mentioned, the BOs, EML statements, and the events, business events from RAP and the event handlers. It could be feature toggles, authorizations, both from the ABAP classic authority checks as well as from the access control logic in CDS. So like that. So now when I'm testing a particular type of an ABAP object, then managing these different types of dependencies will pose a problem for us while writing stable unit tests. So when I say stable, it means that the test should run always against any test user in any test environment, and there should not be any intermittent test failures because of some environment issues or external dependencies. So it should be like a self-sustained test. So to achieve that, we need to have a complete control over these dependencies, and that is a challenge. And you see that these hard dependencies on these various types of ABAP-based dependencies without any isolation is a challenge. So that means any bug or any wrong data that is there in any bug in any of the ABAP-based source code, or any wrong data that is there in database entities, or the way the data being changed in the productive tables, if you're relying on them, or even the authorizations and access control, we cannot have a complete control over it. And anything like this, we will have an influence on my test and can pose a problem to my test outcome. So now this is a challenge. Now that we understood the challenge, how can we ensure that any test failure will be caused by this particular piece of code in green, the code under test alone? So we need to find a way to kind of isolate ourselves, our code under test, from these hard dependencies on the real dependencies that we have, or real artifacts that we have. Instead, that's what in the terminologies I was introducing you to, which is the testable that I just introduced. So if we can replace, so basically these artifacts, if we could replace these artifacts with something that I can have a control over, right? So that's what these testables are. So once we are able to do this, like create corresponding testable artifacts for all these dependencies, and then you should be able to also manage these testables and the life cycle of that. Then, and you should be also able to configure the state or the behavior of these testables. Then we will have a complete control over my dependencies, and also we can ensure that my code under test is fully isolated from the real dependencies. So that's what testables can help you in achieving dealing with this challenge. So now that all the real dependencies are gone, so now we will have full control over the test, as I just said. And then this ensures that when the test fails, I know exactly where the problem would be. It becomes very easy and very fast to fix a test case failure. Okay, so this is important to set up in our test suits. If we want to have an effective, test automated test suite. Yeah, that's what. Now, so just to summarize, so there are three important skills to learn for having effective test automation suite, among others. So how do I pick the right testable mechanism for managing a given type of dependency, right? So we need to identify the dependency that is there in my code under test, and then say, okay, for this challenge, now I have to use a particular testable mechanism to isolate those dependencies. Now, once that I picked that testable mechanism, now I should be able to use that testable mechanism in a proper way so that I can create the right test doubles and configure the behavior of these test doubles, using the right testable mechanism. And this is basically you do it based on your test goal for the test case. And finally, we also need to remember that we need to make our code, under testable, so that it is enabled for dependency injection of these dependencies, so that from the test we can inject, instead of the real dependencies, we can inject the test doubles that we create. So this is something that is explicitly needed in some of the test double frameworks, whereas with some others test frameworks will take care. We will see it later. Now we'll come to the these are kind of basics for this topic. Now we'll come to the core part of this session, so which is about managing dependencies using different testable frameworks in ABAP. So this is about providing you a high-level overview of different testable frameworks that are there and why they are there to solve what problem, and just help you to kind of learn some basics of these testable frameworks, and by identifying some common patterns across the usage of these testable mechanisms in different challenges. So the idea is that we have seen from our experience that some of the developers get confused, or sometimes might get overwhelmed with the plethora of options that are there. So this is just to help you simplify that confusion and help you quickly learn these testable mechanisms and use it effectively without much of confusion. So yeah, so let's see that. Okay, let's see if we can reach that point. But what is not the goal of this session is also that it is not to teach you individual testable frameworks. So that is not the goal of it, but this is just to showcase, okay, given a problem, you have a solution and this is what you need to use, and how probably you can learn them, okay, without confusion and finding common patterns across them. Okay, you will understand hopefully in the end what we are trying to come to. So just before going to the testable mechanisms that we have, so what are the different dependency isolation approaches that are offered in ABAP? Let's have a look at it. So the first one is ABAP test scenes. So this is something that is there since a long time, almost a decade. So this is about you inject the test-friendly alternative value in your code in the runtime when you're testing test runtime. So suppose say you have just these slides might disclaimer, so might have a small font because I wanted to bring all the source code there so that I can better explain. So if in case it is not legible, maybe later you can just little bit zoom in and see. Yeah, so apologies beforehand for that. But here you see that, okay, there is an ABAP method which is having some logic, and which also has a dependency on the currency converter function module, like via call function statement. So now my goal is to test this get counter value and the logic inside it. And this is an external dependency for me. Currency converter is not provided by me. I don't have any control over it. So if there is any issue in this function module, then that should not impact my test that I'm going to write for this get counter value method. So now that means my dependency here is this currency conversion converter function module. So in test seams approach, what you usually do is, I think many of you would be aware of, like you just wrap that piece of code that is posing a problem for you, and then wrap it inside a test seam and you give it a name. So in this case, it's currency conversion. So you need to explicitly write these things, and then in your code under test in production code, and then in the test class, you just say test injection of the same name, and then replace that code with whatever you want, like converted amount is 30 here. That's what always this would be returning that constant, that 30 in this case. So this is what this test seams offers, but then test seams has certain limitations. So as we just saw, that productive code is now being changed with test specific logic. The test seams is there, it kind of pollutes that productive code. And that also means this the code coverage for this part, which is wrapped inside test seam, will not be there. So this is untestable code. And also one more important part is the scope of this test seams is limited to just the current object under test. Okay, so with that, with all these limitations, we typically do not recommend using test seams while writing tests, especially now that you have got a proper sophisticated testable mechanisms offered in ABAP, and that's what we would see in the second one, using testable mechanisms or testable frameworks to manage your dependencies properly. Okay, so ideally you don't need to use test seam now because we have covered all types of dependencies almost. Okay, so now let's dive into the second one, the testable mechanisms. Okay, now let's start with typical steps that are involved while using these testable frameworks and the common patterns to observe. Okay, so the first step is you need to, when you're writing a test for your source code, you need to identify the dependencies of that code under test. Okay, and once you identify the dependencies and the type of the dependencies, based on the type of the dependencies, then pick the right testable mechanism. Okay, so that you can better isolate that dependency. So your testable mechanism is dependent on the type of the dependency that you have. Is it an ABAP artifact, or is it a kind of any BO, wrap BO, or be it function module or database dependency? So based on that, you need to pick the right testable mechanism. So that's the first step. Then the second step is to now actually use this testable mechanism to create the testables for these dependencies. So you would see that we use this term test environment across, and then inject these testables into the code under test. Okay, and then the next step is to prepare test data to be later used in these testables. Okay, the fourth step is to insert. Once you prepare the test data you prepare should be is a very important step, and that's where we see a lot of time gets consumed, because that will drive your test and the test goal. Based on the test goal that you want to achieve with that test, you need to have that suitable test data. So that's why it's an important step. The third one, prepare test data. Once the test data is prepared, then just you insert the test data into the test doubles. The fifth is configure interaction behavior. I'll come to that. And the sixth is verify. Once when the test execution is over, then verify the result. Okay, now let's just go to the fourth and fifth point for a while. So inserting test data into the test doubles. So this step is predominantly if the testable mechanism that is offered is designed in such a way that it offers a state-driven verification. We spoke about it in the initial terminologies about stub and mock. So typically, like a stub, like it's state-driven verification. If it is offering, then the test data that you create, you would be inserting into these test doubles. You would also see the corresponding API like that, insert test data. Okay. Whereas the next one, the fifth one, the configure interaction behavior of the test doubles is for mock. Okay, so for interaction behavior driven verification. So you need to be, there are plethora of APIs that are offered to configure individual calls to a dependency. So if the testable framework is designed to be like that, to be offering that, then you will have this step of configuring the interaction behavior of the test doubles. But in general, when you are using a particular testable framework, it offers either fourth or fifth step, not both. There is one exception to that. We'll come to that later. But either one of these styles, it would be using. Okay. So we will see when in the next slides the difference between them. And finally, the verification or probing the result. So normal circumstances, the general standard asset statements from ABAP unit also you can use. But if it is a mock or interaction behaviors, if you are configuring, you can also expect some verification API being provided by some of these testable frameworks to specifically verify some aspects of the test execution. Yeah, again, so this is just a suggestive list of steps and patterns. So to just make it less overwhelming for you while learning these different TDFs. So it's not necessary that every feature and pattern is available in every testable framework. So it depends basically on the need, basically the use case, and also the design of the testable framework. Now, what we are going to see later in the slides is I'll go through a brief of each testable framework in each of the slides, and then I will kind of present where you can identify these steps, okay, at which part of code, so that you can apply these as patterns when you learn these different testable mechanisms while using them. You can look for these patterns. Okay, that's a goal of this session. So now let's start with the first one, the ABAP object-oriented testable framework, ABAP over TDF. The code under test is you have any ABAP code anywhere. ABAP, it could be in ABAP class, it could be in function module, wherever it is. But the type of dependencies that you have is ABAP object artifacts, which is classes or interfaces. So if that is your dependency type that you want to isolate from, then like you have an object and method call on an object which you want to isolate from, then this is a framework to use. So you are seeing that code under test is something like this. In this case, the code under test is an ABAP class in itself. Okay, but it could be anything, any ABAP, anywhere, ABAP function modules or anywhere. So say calculate total price is something that I have written my own logic. And this is what I want to test. Now this has some loop. So I just wanted to calculate the total price, but I have a source currency, but I also want to convert it into my local currency before I present it to the, say, end user based on their local target currency. So I again use the currency, general purpose currency converter, which is not developed by me, by somebody else maybe. So suppose say if that is a class, if that has an interface IFTD currency converter is the kind of dependency that I have, and I create an object of it and then call this convert method. Okay, so the one here represents, here I can see you can see the legend. The legend here is basically these steps, just for your reference. So this is just to identify the dependencies. So I know that, okay, my piece of code that I want to test has this dependency on the currency converter. Now that I have identified the dependencies, I can now create the test double. So I know that, okay, this dependency is of type interface. So that means I have to use ABAP over TDF to isolate this dependency when I'm writing test for calculate total price. So that's what I'm going to do now. This is my test on the right hand side. So I'll create this test double. This yellow mark part across the slides is going to be the dependencies. Okay, this is just to identify the dependencies. So CL ABAP test double is an API from this ABAP over TDF framework, and then say test double create. So you create a test double for what? For your dependency. In this case, it's this interface, currency converter. Okay, that's what is marked as 2, creating test doubles. Okay, and in this framework, you would also need to specifically inject this test double into your code and test in the runtime. So that's why you see here again, inject test doubles here as a separate one. So how it is being done, like, remember the third skill that I was talking about when I mentioned 3 skills. So you need to make your code testable. So that means I have this dependency on this interface. So instead of creating an object of this in this class, so I enable the dependency on this to be given to this class. So one of the mechanisms, dependency injection mechanisms being used in this example is constructor-based dependency, where I just have a constructor. So whenever we create an object of this source code under test, say CL ABAP over TDF demo, this is code under test, I have to supply the caller of this class has to create that object of currency converter and then supply that dependent object currency converter. So with that, so it also enables my test to supply, instead of the real dependency, supply the test double for that. So that's what is happening here. So yeah, sorry for this. I think it should have been a different new version of creation of objects I should have used. So this is what is being done here to inject the dependencies, inject the test doubles into the source code. Later, you would see that in other testable frameworks, this is not required as an explicit step because this is being taken care of by the framework in all other testable frameworks. So this here, you have to do that. And then you actually configure the call. Okay, this is about interaction behavior driven verification. So each call to this convert statement on your dependency, you can configure. That's how this framework is designed. So this is like this 5th one, the configure interaction behavior. That's why you see this insert test data is grayed out. That's not applicable here. This is more like a mock. Now, I offer this test data when I'm configuring the call, saying that, hey, you return, whenever this is getting called, you return 80. But whenever this is getting called using this input, okay, you return this. So here, you can also define like for how many times, okay, this kind of thing to be replayed, or you want like for first time when it gets called, you return say 100, next time it gets called, you return say 50, or for different inputs, you can configure different outputs. So that's what you'd see here. So all these options are there. This is not showing all the possible APIs. That is not the scope of this session, but this is just to give you an idea. Okay. So now you can configure the call like that, and with various options that are there. You can also, in fact, configure it to throw an exception and then see how your exception handling logic is, if in case you have something like that. Okay. And that gives you a hook to, okay, test different aspects of this code in your code. So that's what is happening here. You execute the code and then you have your assert statements. That is about ABAP over TDF. So now coming to ABAP SQL TDF or OpenSQL TDF or OSQL TDF, we used to call it like that before. Okay, again, the code under test is any ABAP code which contains a ABAP SQL statement. So naturally, the dependencies are the dependencies of the ABAP SQL statement, which are like database artifacts, tables, CDS entities, etc. So now here we see the code under test could be anything. So now I have in this ABAP class method, I have a couple of ABAP SQL statements. Okay, so there I have to identify what are the database dependencies that I have. In this case, you would see that there are two, okay, sales order and business partner, but these are also repeated in the next SQL statement, ABAP SQL statement in this case. So I identified that, and now I come to the test. Again, we will see that now that I know that the dependencies I have is database dependencies, so I know I have to use a ABAP SQL TDF. Okay, so I use CLO SQL test environment create, and then I provide in the dependency list, I provide all the dependencies that I need to, create testables for. So these are identified, these yellow marked ones, sales order and business partner, and these are the database artifacts that I provide here. Okay, that's the second one. So you see the numbering here. Okay, from now on, I would not specifically go through that for everything. And then you prepare the test data like this. In this case, it's a value hash statement. And then you insert the test data as a fourth step, because this is more about state-driven verification that this framework offers. So you have to insert this test data. So that means you're taking that state of those tables or testables into a particular value, and then that drives your test. So this test data you would be giving based on the test goal that you have. And then finally execute the test and have such statements. So here you see the fourth step is there, but not the fifth step, unlike the previous one. And here you would not also get, you'd also need, do not need any specific verify or probing APIs from this framework. You can use the standard assert statements from ABAP unit. Now let's see the function module testable framework next. So any ABAP code having call function statement, just like the previous one, any ABAP code with having OpenSQL or ABAP SQL statement, this is with call function statement, dependencies, function modules. So here I have the code under test, the method which you have seen earlier in the slide when I was explaining the test scene is exactly the same. And then here I have a call function statement on the currency converter. So I already identified my dependency, which is this. So it's a function module. So I need to use function module TDF. So function module TDF offers this kind of an API to start with function test environment. Previously, you have seen CL OSQL test environment, CL function test environment. So you get that. Okay. So, and then create environment create, and then you basically provide all the dependencies that you have. So if suppose there are more call function statements, you can mention like this. That's why it is mentioned like that. So, and then this will ensure that the test doubles are created for this. You'd also see that separately, we don't need to inject these dependencies into the source code. That is all taken care of by the framework, even for the OpenSQL testable framework as well. And now you basically also configure test data. So function module testable framework falls in the category of interaction behavior driven, verification. So basically like a mock, it offers that. So that means you would be able to configure each and every call to the function, like each and every call function statement you can configure the behavior of that in your test. Okay, so that means if you have say 3 call function statements, then you would have at least 3 configure call statements. And similarly, if the same call function module is being called multiple times, you can also configure the behavior for each call to the same function module separately. So that's what this offers. So that means you would also need to provide this test data for this call function. So in this case, the test data is like input config and output config. So given a particular input, then I want to return this kind of an output. So that's how I configure the behavior for interaction behavior between this source code and the function module double, okay, that we create. So this is, I call it as like a test data preparation step or test data configuration step. So I prepare this test data or configure this test data, and finally in the configure step, I supply this test data. Like when input config, then set output of this so and so config. Okay. So that means whenever this call function statement is called from your test, then with this in kind of input with say $100, then it would return 80 euros as an output. Okay. Again, the same thing you can configure like for how many times it has to return like that. It is like any number of times, or you want to say no, only for 2 times. Third time onwards, you want to return something else, or you want to throw an exception. All that you can configure. You can actually configure rising exceptions. If this call function statement rises an exception, then how is your exception handling logic that is there next to it? So, but then here you see that you are not actually touching your code under test. It's production code. You don't need to touch it at all. Okay, that is not needed at all. And there are no restrictions like what the test teams are having. So you can achieve it here in this case without that, using this testable mechanisms. And finally, since this is also a mocking framework kind, there are certain verification APIs that are being offered. You can check, like you can verify how many times actually this dependency has been called, this function module has been called. In fact, how many times this is being called with a particular input. So that's also one advantage with these APIs that are provided for this input prepare data, because you can reuse those input config objects, this data later, well, in the verification API as well. That's how we designed it. So you would have multiple options to verify actually. Okay. Now let's see, yeah, a different type of stuff here, which is ABAP Authority Test Helper. Okay, this is slightly different. Now I have here ABAP code which has an authority check statement. So basically, I have some authorization checks. So based on certain authorizations for a user who is executing that code, I would like to take a certain path in my logic. Okay, this is my logic, right? In say update admin DB, I want to update admin DB with some user data. But before that, I need to know if that user who is trying to update that admin database with some specific privileges, right? So we would use authority checks for that. So here you see that, suppose say you have, okay, this is one of very complex slides. The font size would be even small. Please bear with me for this slide alone. Here you would see that the authority check is on an authorization object sdevelop. So basically, if the user is having a sdevelop authorizations, specifically to create an entry into this Z user admin table. Okay, so that is the authorization that I'm looking at in my source code. If the user is having it, then I would allow the user to insert the data into this table. If not, then in this case, like I would have an asset fail saying that user not authorized to update or some other thing. It's my logic, whatever it is. So these are just simple examples that we have picked. Now how the test looks like, okay? So here, now that I identified my challenge is with this authorization check, because authorization check is something which is a very complex thing because anybody can run the same test, and then each user can have different authorizations. And based on the authorizations of the user who is running the test, who is executing the test result can change. And also the same user can have different authorizations in different systems, right? So how can I ensure that I have the test stable at the same time, ensuring that the test actually checks for certain things that, hey, if my code is having sufficient authorizations, my logic is sufficiently protected with these authorizations or not. How can I have a test to test these things? but at the same time, the test should be stable across systems for all users whenever they run. Okay, so now let's see what is on offer with the authority check test helper. Okay, so there is a reason why we did not call it as test double framework, because actually, technically speaking, there is no test double being created here. Okay, you don't need to bother more than that. This is technical complexity which we have dealt it within the framework, so it is seamless for you. What you need to do is you need to prepare test data. Okay, the third step. Okay, so what is test data here? The test data here is to prepare your authorization object, okay, that you want to while testing this. So then for that, this framework offers a couple of APIs. So CL, unit, auth check, types, def, so on and so forth. Okay, so role auth objects. So I'm using my pointer here. So please follow that. I know it's difficult with font size. And then you prepare this like this, like for SDevelop, I want to give for my test user. So for ACTVT field, say display, edit, and create authorizations on, say, on this table, Z user admin. Okay. Or I can also configure saying that, oh, I want to test the, like if size sub RC value is not equals to 0, means if there is no authorization, what am I doing? Am I still allowing? So if I want to test that, maybe I can also say, I can remove this create from here and then reproduce that scenario. Okay. So with that, I can test whether my intent is met in my actual code or not while writing tests. And this also acts like a very good regression suite for you later when these authorization checks are changing by mistake or by inadvertently, then the test will immediately catch these things. Not just for this, but across the different testable frameworks. So here again, coming back, so I prepare this object size. I'll not go into the details of all the APIs. So I prepare this entire authorization object set. Okay, that is the prepare test data part. Okay, once the authorization set is prepared, I now use further APIs from this framework, authority check, controller, and then from the controller, I restrict authorizations to. So what is that I am doing here? So it is basically that I can only, okay, I'll put it like this. Maybe you might be already thinking that, hey, oh, this is good. Now in the test, I can give any authorizations. I can configure any authorizations that I want. Maybe I don't have some admin privileges, but I can still have it here and then supply it, and then I can access something, right? So no, I mean, that is not allowed. So that would be a security violation. So what is being done here is that one cannot have additional authorizations than what you already have, a test user is having in that system. Okay. So you can only restrict that authorizations to a specific subset that you are already having. Okay. And hence this naming is also like that, restrict authorizations to. Okay. And then this object set that you have prepared. For example, what if I am running the test, executing this test in a particular system, and I don't even have the create authorizations, but I'm trying to create here, then this restrict authorizations too will give an exception. It will not be allowed, even if you configure it there. Okay, so that is taken care of. So you don't need to worry about the security violations. But this provides you a way to restrict authorizations to a particular object set and then move on. Now you can actually check if it is successful logic as well as failure authorization check. All of these things you can reproduce with different test cases here. And finally, we also offer a kind of a sophisticated probing mechanism. There would be an execution log. So you can actually check like, okay, which all authority checks in my source code got or failed, and which are passed, and which authorizations which are supposed to be executed successfully got failed, and vice versa. And a lot of combinations. You would see a lot more here in this API, get authorization check execution log. Okay, and then you can have multiple options there, probing capabilities. Yeah, so with that, now let's go to the next one, that RAP TDF. So basically, any ABAP code containing EML statements, similar to any ABAP code containing ABAP SQL statements or call function statements. So EML statements. With EML, the dependency is on the wrap business object. Okay, so like business, like behavior definition or behavior implementation via EML call. Now, same thing. So get discounted price for travel is my logic. So wherein for a particular travel, I want to give some discount. Okay, that's my logic. So first I have to get that travel. I have to read the travel from the travel BO. So that's what this EML statement is doing. Read entities, and then say for this travel ID 101. Once I read it, I just pick the value. If it is not there, that entry is not there, and then discount is of course 0. If it is there, then I just calculate the discount that I want to give, say 5% in this case, and then that would be my discounted price. So this is what this dependency on the BO, okay, this is not mine, is what I want to isolate. So dependency is on the BO via this EML statement. Now I know that I need to use a rep BO TDF for that. So here you would see again some test environment create. In this case, you see environment config because we also offered some environment configuration preparation before supplying to the create. And here you supply this behavior dependencies. In this case, there is only one travel, right? So you mention it here, and then you prepare the environment config and then create the test environment, BO test environment for that. Okay, I'll come to the other naming later. Okay, and then okay. So this wrap BO TDF is one exception wherein we kind of offered both approaches, which is state-based verification as well as interaction behavior-based verification like stub and mock, but both are independent. You have to pick for a particular test, either this approach or that approach. You cannot use it. So how we did that is that for the state-based verification mechanism, we created test double for transaction buffer. Okay, and then you have to insert the test data into that transaction buffer double, and then that drives the kind of test the test result. Okay, so that is one approach, and the other approach is like function module testable framework. For example, the call function statement, like you can configure call for each individual interaction with that call function module. Here it is individual EML statement. So that is like interaction behavior based approach as well is provided. Why we did that both here is because one offers convenience, which is transaction buffer double approach. That's what users felt that, hey, that is easy to use. So, but then we could not solve all the use cases with it. So that means most of the usual ones you can use it to solve, but for some of the things we cannot technically solve it. So whereas the mocking mechanism solves each and every use case, that if you use that, it will cover everything. So only for the sake of convenience, if you want, and if that use case is supported, you can use this transaction buffer double approach, or else the mock EML approach is what we would recommend. And today I'm just, for this session, I'm just only showing this one approach, transaction buffer double approach. And remember, these two approaches are mutually exclusive. You cannot use both in the same test. Okay, now that this is there, so because there is a double being created for transaction buffer, so we also allowed that you can use the modify EML statement on the travel BO, like provided you already did this environment setting creation for this travel BO. You can use this to actually insert test data. So it's like an equivalent of insert test data. Okay, and this is the test data. Okay, you can modify the entities of this travel BO and then insert the test data, and then later you can check your logic. Okay, now the last one, the serious testable framework. This is a slightly different one in the sense that so far you have seen that we have testable frameworks to tackle different type of dependencies. So here also, yeah, largely it is same, but it is also that until now the source code was ABAP code. Here the source code and the test is CDS entity. So we need a mechanism to even test the logic. The lot of code pushdown logic is going into CDS. So we need a mechanism to test this CDS, the logic inside the CDS entities, and that's where the CDS TDF is. So CDS TDF, again, the type of dependencies is same like the database artifacts. So it's mostly similar to what you see with OpenSQL TDF. But the difference is, if your goal is to test the logic inside CDS, then use the CDS testable framework. Or else, if I have my ABAP code, but I have an OpenSQL statement, I don't want the dependency on the database artifacts. Not necessarily that I want to, test the CDS logic. Then use ABAP SQL TDF. Okay, we often see that people get confused between these two, when to use what. So you need to remember that CDS TDF should be used only if your goal is to test the logic inside the CDS entity. Okay, or else use ABAP SQL TDF. Okay. So again, the CDS entity, a simple one. So here you see that there are two dependent artifacts in this CDS. So the CDS here is CDS framework sales order item, and then SNWD SOI and SNWD PD. These are the dependencies. And then I write a test similar to CL, OSQL test environment and function test environment, BO test environment. Now you have CL CDS test environment. It's kind of same ritual, right? So you identify these patterns. So that's why we have marked this code. Sometimes a similar pattern is being done with different testable frameworks in slightly different ways. But once you understand this difference, you will not get confused. So that's the purpose of this session. So it helps you to identify these patterns. So now you can learn easily and then use it effectively in your code. Yeah, you create test environment for this, give a CDS, and it actually picks up all the first level dependencies, and you can basically test, have a unit test for this. And then it also identifies all the first level dependencies and creates testables for them and injects those dependencies. All that is taken care of. Later, you have to just create test data and insert test data here and have a OpenSQL statement on it and run, execute the test. CDS TDF also offers various other capabilities, like support for testing your entire hierarchy. Means not just unit testing, but I want to test the entire hierarchy of CDS, depending on other CDS and so on and so forth. You can pick and choose.
Yeah. I don't know, but really, this gave the boost to JavaScript being the script language, a Java syntax lookalike script language for the browsers.
Yes. It just so happened that some of the
bad things also.
The standard constructs, like the four, look very C-like, which was very Java-like, which sort of helped
exactly.
that.
Exactly. So these were some compromises. Also, the constructor idea is basically, yeah. But I think that's good old times things, right?
I thought JavaScript started going downhill when they introduced classes in ES6.
Exactly, and actually, it's actually the start of overloading the language with too many language concepts, I think.
Yeah.
But if you use them nicely, it helps you to write code that authors can understand better. But you should still think in it's just a prototype, right? It's just a function.
Yeah.
A class is just a function.
All the way down.
Yeah.
By the way, sorry to interrupt. We're 1 minute away, so I'm going to in a moment I will tell us all to go quiet.
Yeah, and DJ. I also checked with Sina. She's in the other live stream. It has not ended. Okay, so should we give it some time?
Sorry, say again, Ajay. Is it has ended or is not ended yet?
Not ended. So should we give some time?
Yeah. Can you tell us to end it?
Yeah, I'll tell.
Because I'm still seeing here the error duplicate stream key selects a new key below to go live, so we can't go live yet anyway.
here as well. Not that I'm gonna do something, but I'm here.
Thank you, Kevin. Hello and welcome. Yeah, it's YouTube Studio is still saying the testable mechanism session is still live.
Yeah. Yeah, so he's ending, so let's just give it a moment. He will just tell me, and it is.